All right, now we're going to work on reading electron configurations, which is way easier. Okay. I just copied these off of the internet. This is the answers to somebody's worksheet. We will figure them out. Blue will be a good contrast. All right, when you're reading electron configurations, there is one step, and it's super easy. Add the exponents. 2 plus 1 equals 3. This number is always the atomic number of your element. So it's going to be hard to see because I just kind of had to fit it on the screen here. But you find element number 3 right here in blue, bang, lithium. And that's it. Those are the 2 steps for reading electron configurations, and it always works. Now, I don't have a calculator in front of me, but I would suggest, if you notice, I actually write out the math. Do that. You have no idea how many times I've seen silly mistakes like 2 plus 1 equals 4. And a kid in AP chemistry gets a B on a test in their first time in life because they were trying to go too fast, right? You have plenty of time. Take your time. Getting it correct is way more important than getting it done first, right? Next example, 2 plus 2 plus 4. 2 plus 2 plus 4 is 8. So we come on down to our periodic table. We find number 8. Now, I happen to know my periodic table pretty good. It's right there. And the name of number 8 is oxygen. Now notice it's starting to get wonky. We got bigger elements. 2 plus 2 plus 6 plus 2 plus 6 plus 2. 2 plus 2 plus 6 plus 2 plus 6 plus 2 is 20. So come on down to our periodic table. We find number 20. There it is. It's calcium. Just come back up. And the correct answer for that third example is calcium. All right, next one. Oh, that's a lot of numbers. Let's see if I can find another color that pops. Orange works for me. 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 2. All right. Remember, that's just adding all of these exponents. And that is 22. I don't know about you. So we come on down here. We find element number 22. It's real close to calcium. It is, titanium. That's one we have all heard of, I think. And so that element is titanium. The process stays the same even when you start dealing with super big elements, right? And like that second one on the screen here, it's a pretty good example of go get a calculator, right? 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 10 plus 6 plus 1. 2, 2, 6. All right, so I've got 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 10 plus 6 plus 1. All right, so that's 10, 20, 30. I believe I got 37 from that one. Let's come on down. 37, sweet. There's number 37. Is there a way that we can check our work this way? Yes, come on back up. And look at this let me erase a little bit so you can see it better. If you look at the end of it, it ends with 5s1. So if we go to our periodic table, we find fifth period, 1, 2, 3, 4, 5. It's in the S block, and it's the first element. Right? So that's a way we can check work on this kind of problems. But Mr. Jones, why didn't we just start with doing that? Because there are exceptions, and if you try and skip steps like that, you will end up being incorrect pretty often. Yeah, it'll be the difference between an A and a C. So I know it's a little bit more work, but honestly, you get to use a calculator, so be cool. I don't want to do this one, but it's what I get paid the big money for. 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 10 plus 6 plus 2 plus 10 plus 6 plus 2 plus 14 plus 10 plus 2. Just reading that. 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 10 plus 6 plus 2 plus 10 plus 6 plus 2 plus 14 plus 10 plus 2. Kind of wish I had a calculator at the moment, but I'll do it a long way. 2 plus 2 plus 6, that's 10, 20, 30, 36, 38, 48, 54, 56. 56 plus 14 is 70. 70 plus 12 is 82. Yikes, 82. Let's see if it matches up with 6p2. Number 82. Oh, hey, it's lead. That's another element you probably have heard of. And it should be 6p2, right? That's the sixth period. This is the p block. 1, 2, second element. So, yes, looks like I got that one right without a calculator. I am proud of myself. All right, and one last example. This looks joyous. 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 10 plus 6 plus 2 plus 10 plus 6 plus 2 plus 12. 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 10 plus 6 plus 2 plus 10 plus 6 plus 2 plus 12. All right, that's 10, 20, 30, 38, 48. 48 plus 8 is 54, plus 12 is 66. Let's see if I got that right. 66. Where is element number 66? No, looks like I didn't get that right. Let's go back and check my counting. 2 plus 2 plus 6 is 10. 2 plus 6 plus 2 is 10, plus another 10, plus 8, plus 18 and 12 is 30. Ooh, I missed a 2 somewhere. Right? Use a calculator. Don't be fast and sloppy. It's not 68 or 66. It's 68. Right? So come on down here. Element number 68 is erbium. There we go. So that's my illustration of you trying to go too fast and you forget to add 2. And so you get chemistry wrong, right? So the chemistry part of this is actually pretty easy, right? Just make sure you're not trying to go too fast or be sloppy like I am. Or else you're going to make silly mistakes. All right, well, that's all we have for reading electron configurations. Don't forget to like and subscribe. Thank you very much.